So section 3.3, we're going to discuss the slope-intercept form of the equation of a line. We'll begin with this example here, and just kind of maybe a quickie review of some of the things we did to graph lines. So on an exam, I'll typically ask you to graph 3 points when plotting something. So let's come up with some values of x and get the values of y. On an exam, make sure that you can find the x-intercept, y-intercept, excuse me, other way around, x-intercept, y-intercept, and that third point. But this one's kind of a special one because you've got y solved for already. Y is already by itself. So let me just choose a couple of values for x here, 0, 2, and 4, and plug them in for y. If I plug in x equals 0, what do I get for y? Negative 2, right? 0 times 1/2 is 0, minus 2 is negative 2. How about if I plug in a 2? Half of 2 is 1. 1 minus 2 is negative 1. And last one, 0. All right, so I get these points here. And the line's already graphed, so that's good. But let's take a look at something. The other day we went over the slope of a line. Let's kind of do a visual calculation of the slope. So the slope was the rise over the run. Let me graph the run. Let me graph the rise. So m is the rise over the run. How much of a vertical rise is there? A rise of 2. How about the run? How far of a run are we making? 4. So the rise over the run is 2/4, or better yet, 1/2. Now I mentioned a minute ago that one of the things that I'll want you to find is this point right here, the y-intercept. What are the coordinates of that point? Thank you, 0, negative 2. And in particular, notice that the y-intercept is negative 2. Okay. Well, there's really two kind of coincidences here that I want to draw your attention to. One is that the y-intercept is negative 2, and negative 2 is there in our equation. The other is the slope, 1/2. 1/2 is also in our equation. Do you think those are just coincidences? No, you're right. It's always going to happen. Anytime you have your equation of the line in slope-intercept form, as y equals mx plus b, then m is going to be your slope, and b is going to be your y-intercept. And that's really handy. That means in order to find the slope and the intercept, all you have to do is solve for y. And then you can just read it off of the equation. On your exams, I'll always ask for your equations in slope-intercept form because it's a very handy form of the equation of the line. Let's practice with a couple, starting with problems number 12 and number 20. Y equals 7x plus 3, and y equals 4/5 x minus 9. So the goal for these problems is to find the slope and the intercept. So m and b, m and b. So Nick, how about number 12, slope and intercept? Well, the number in front of the x is going to be your slope. So that would be a 7. And the remaining number over here is going to be your y-intercept. So, nope. That's all there is to it. Do you want to try the next one? What's the slope? Cool. There's a couple quick points for you on an exam. All right, just knowing that. Thank you, Nick. Let's take a look at problem number 22. And the reason I want to look at 22 is because it's written a little bit different than you could write it. There's nothing wrong with writing it like this, 237. But it might be more helpful if we realize that you could write x over 15 a couple different ways. You could write it, for instance, as 1/15 times x minus 3/4. Having written it like that, what's the slope and what's the intercept? Thank you. Slope is 1/15 and the intercept is negative 3/4. Cool. Let's try a few more, and the goal is to start trying to introduce some more things to think about. Problem 26. Y equals negative x. A little bit different than the other ones because a couple things are kind of implied. But still, you've got y solved for, right? Y is all by itself, so we can figure out the intercept and the slope. Which one do you want to start with? Excellent. M is -1. Even though it's not written, it's kind of understood that there's a -1 out in front of the x like this. So the slope is -1. Yeah, b is 0. So if I wanted to, I could write this as -x plus 0. I probably wouldn't, but I could. So we got a slope of -1 and a y-intercept of 0. What does it mean for something to have a y-intercept of 0? What's that going to look like? No, not a vertical line. So let's take a look here. Let's see. So anyone else? What's it mean that we have a y-intercept of 0? Yeah, goes through the origin. Now think about what a negative slope means. As you move left to right, is your function getting taller, or is it horizontal? Is it vertical? What's that negative slope going to look like? It's going to go down. Yeah. So y equals -x. There you go, right through the origin. A nice line that goes through the second and fourth quadrants. So nice. All right, so at least that matches our expectations. Let's try problem number 28. So problem 28, y equals 30. I guess it is in slope-intercept form in as much as you have the y solved for. Let's think about this in a couple ways. It should blend nicely with some stuff that we learned about slope in our previous section. First of all, does anyone know what the graph of this looks like? How would that graph appear? Y equals something is just going to be a horizontal graph. So that's something that I do want you to know is what those graphs look like. So let's take a quick look at that. Y equals 30. And zoom out a little bit. There you go. Horizontal line. All right. Someone else here. What's the slope of that line? We went over this the other day. We had a handout, remember? What's the slope of that line? 0. Good. Slope is 0. Can we make sense out of that based on the equation? I mean, do we have to look at the line to realize the slope is 0? How can I justify it here? Yeah. I could think of it as 0 times x plus 30. So that makes sense out of it. The coefficient of x is 0. That's your slope. Okay, yeah, we got a horizontal line. Makes sense. Something that I do expect you to know is the slope of a horizontal line and what their equations are. Please don't miss those. Those are giveaway points. How about problem 34? 2y equals x plus 20. Is the slope 1 and the y-intercept 20? No? Victoria, what should we do with that? Good. You need to get y by itself. So we're going to have to divide everything by 2 here first. So we'll get y equals x over 2 plus 10. That's a little closer. I guess it depends on you and how comfortable you are with those types of fractions. Let me ask again. What's the slope and what's the intercept? Good. The slope is 1/2. Now you can see that if you rewrite this as 1/2 x plus 10, that makes it a little bit clearer. So the slope is 1/2 and the y-intercept, no problem with that. That's just a nice 10. Okay. One last one like this, problem number 42. Negative 4x plus 4y equals 9. Probably a couple things we're going to need to do to get y by itself. You can't start out and look at this and say, okay, the slope is negative 4 and the y-intercept is 9. That's not even close. So tell me, what should I do first in order to put this in slope-intercept form? All right, let's add 4x to both sides. 4x here, 4x here. That's 4y equals 9 plus 4x. Okay, that's good. Then what? All right, we'll divide everything by 4. So I get y equals 9/4 plus x. If it makes you feel happier, you can change this around as x plus 9/4. It still says the same thing in terms of the slope and the intercept. What's the slope here? 1. And the y-intercept? 9/4. What's 9/4 as a mixed number? 2 and 1/4. Let's just go back and take a quick look at the graph and see that that matches our expectations here. So we'll shut this one off. The cool thing about Desmos is you don't have to necessarily type in the equation with y solved for. You can just type it in as is. So I can type in negative 4x plus 4y equals 9. And it'll come up with a graph. Now let's zoom in here dramatically. That's looking pretty good. Let's ask it for a point here. There's our point. 0 and 2 1/4. So it actually matches our expectations pretty nicely. We're okay with those first, 6 or so examples. Just asking you to find the slope and the y-intercept of a line. Let's try moving on a little bit and finding the equation of a line given a point and a slope. So point slope form of a line. So if I wanted the equation of a line passing through a point with a particular slope, it comes from this formula. So a line with slope equal to m passing through point, we'll call it x1, y1. Here's the formula here. Y minus y1 is equal to m times x minus x1. You need to memorize that. It's going to get a lot of work done for you. There's going to be a lot of good problems that will reference that, but you need to have that one memorized. Okay, so let's take a look at problem number 46. Pardon me. So in problem 46, we're trying to find the equation of a line with a slope of 4 and passing through the point 0, negative 1. Let me see if I can't get that focused better. There we go. There's a couple ways you can do this. Let's think first of all of two things. One is y equals mx plus b, and the other one is y minus y1 equals m times x minus x1. In general, when you do these types of problems, this is the formula that you're going to be stuck with. You're going to have to plug into this formula. We'll spend some more time on that in section 3.6. For now, let's take a look at this point. Can anyone tell me anything special about the point 0, negative 1? What's unique or special about it? Well, it's just a point, but where is that point? Can you visualize it? Yeah? It's on the y-axis. So this really is your y-intercept right there. That's b. So b equals negative 1. And they've given us the slope, right? The slope was 4. So, yay. So we can plug it in. Y equals 4 times x plus negative 1, or better yet, 4x minus 1. Now just kind of a little warm-up for section 3.6 here. If you regard this as x1, y1, then I can plug things into here and again find the same equation. So it'd be y minus negative 1 equals m times x minus, or excuse me, equals 4 times x minus 0. Taking care of the double negative and distributing, I get y equals 4x plus 0. If I subtract 1 from both sides, I get y equals 4x minus 1. So it still works. This is a very general form of the equation of a line. You can get a lot of work done with it. Yes, sir.
So always the y-intercept is going to be b.
The y-intercept is going to be a point where the x-coordinate is 0, and then that remaining coordinate is your y-intercept. So if you have an x equals 0, that's your b. Okay, let's try another one like that. Problem number 48. We don't have to do it this way. M equals 1/3. Passing through the point 0, negative 5. See if you can't come up with the equation. Okay. Someone can give me an equation. Ooh, let's see. How about up front? Good morning. Thanks. Y equals 1/3 x minus 5. Nice. Here's your B. And here's your M. So, yeah, 1/3 x minus 5. Nice. Let's work things kind of the other direction. I'll do one, and then I'll let you do one. So I'll start out with problem number 60. Or excuse me, I'll start out with problem 58. Let you do problem 60. So this time we're starting out with a graph, and you're asked to find the equation. So we'll try and find it by recognizing that we could probably find something in slope-intercept form. So problem number 58, y equals mx plus b. All right, so your chance here is you got a golden opportunity to do the easy part. Can anyone figure out one of these two values, m or b? B would be 2, right? Because it's crossing the y-axis at 2. So b equals 2. Now, as far as your as far as your slope is concerned, well, we have to be a little bit more careful. Slope is the rise over the run. So let's pick 2 points on this line. There's one here at 0, 2. Where's there another point? Is there another point that it goes through kind of one of the nice corners on this graph? Good. So at 1 and negative 2, there's another point. So let's see if we can't calculate the rise and the run in doing that. So if we're going starting from here over to here, what's that distance? So the distance horizontally is 1. How about the distance vertically? How far have we gone to go from 2 all the way down to negative 2? Almost. Negative 4. Since we are higher here than we are here, we went down by 4. Overall, the equation of our line is y equals negative 4x plus 2. Are we okay with our conclusions on 58? Because I'm going to give you problem 60 to do and then perhaps walk around a little bit or something like that. But are we okay with our conclusions there for 58? Yeah, you can pick any point on that line. Now, the one problem that you might run into is that some of them are kind of harder to estimate than others. I mean, it's like, well, what are the coordinates of this point here? Well, it looks like negative 1/2 and 3. I mean, you could work with that and make it work, but it's tougher. So what I look for are points that are nice integer points, points that go through, one of the grid points. And there was one right here at 1, negative 2, and there's another one up here at 0, 2. You could go further up. Yeah, actually further up doesn't get us one, does it? So at that point, you'd have to estimate. Yeah, but good question. You could pick any point. Okay, here's problem number 60. Why don't you give that one a try? I'll walk around, try and help out. It's supposed to be your y-intercept there, right? Where does the graph cross the y-axis? At what point? -4. All right. As far as the run is concerned, we're going to start out here and go over. These look like 2 points that I would use right there. Those two. So there's a couple things I want. I want the run, which is over here, and then the rise, which is up to here. So the run is 4. What's the rise? 6. Okay, so let's put those things together. So we'll choose these 2 points, this one and this one. Run of 4, rise of 6. What's the y-intercept? -4. So as far as this problem is concerned, for problem number 60, y equals mx plus b. B was -4, m was 6 over 4, which reduces to 3/2. So you can write this as y equals 3/2 x minus 4. You can put plus -4, that'd be fine as well. Yes, sir.
I have a question because I got something slightly different. Instead of getting, I still got 3/2, but I got negative, and I didn't use the same point.
-3/2?
Yeah.
Well, regardless of where you find your points, you should still get the same slope. Because, and that's, okay. Yeah, you can use 1 and -2. That would work. Those are nice corner points or grid points. So yeah, that would work. But even if you did that, you should still get the same slope. Yeah, actually, you know what? 1 -2 is not really 2 -1. Yeah, 2 -1 would work. So 2 -1, you're going to go over 2 and up 3. So that should still work. It does work. Now just take a look at the form of this line. Does that look like a positive slope or a negative slope? Yeah, it looks like it's a positive slope. So if somehow by accident you ended up with a negative answer, a negative slope, you might want to look back and go, well, wait a minute, something doesn't look right. Is there another? Yes.
I want you to repeat what you did with the 4 and the -4. Like, not with, like, with the points you choose. What did you do?
Sure. Okay, so here's one of our points right here. And the other point that I chose,
It's
4 and 2. 4 and 2. So those 2 points. So the run, let's see, we're going to have to go over to the right until we're underneath that point. So 1, 2, 3, 4. The rise is the vertical change. So 1, 2, 3, 4, 5, 6. Yeah. So the rise is 6, the run is 4. You form a little ratio between those two, and that's your slope. 6 over 4, or better yet, in lowest terms, 3/2. Like this? I'm very, very comfortable with like this. Yeah. I'd actually probably rather not see it as a mixed number for the slope. It's nicer for me to have as a fraction. If you wrote 1.5 x minus 4, I wouldn't have any complaints about it. That's fine. It's still an equivalent thing, so I'm not going to worry about that part. You want to try and find points that are grid points. Points where the line passes through, a horizontal and vertical line so that it's easy to figure out which point they are. So for instance, it doesn't quite look like it passes through a grid point right here at y equal -2. y equals -2, it looks like 1 1/3 maybe. I don't know, but I don't want to get in the estimate of trying to, or the task of trying to estimate these points. I'd rather just say, well, you know what? It definitely goes through 0, 4, so let me pick one of those as a point. Or it goes through 2, -1. That one's pretty clear. So pick places where the line actually goes through a nice grid point. That way you don't have to worry about trying to guesstimate. Okay? Does that help out? All right, thank you. Appreciate the questions here. Sure. Let's try problem number 62 then. Let's agree where we have grid points. Certainly we have grid points at the y-intercept. That would be here. Where's another grid point? Where's another xy coordinate that, you know, it goes straight through that grid point? All right. That looks like a good one. 6, -2. Sure. That's the one that looks the best. Here, not so much. None of these look that good until you get down to
So we find
6.
the one that's like
That it goes
exactly.
straight through. Yeah. And that goes straight through here. You know, that doesn't look like it's right on one of those crosshairs. So, look, on an exam, I'm not going to make it that tricky that it'll be hard for you to find those spin. This one is a little bit tricky because, yeah, it looks close there. Especially, you know, given the fact that some of you might be looking at it in the book and it's really small here. I mean, at least here it's zoomed in. Yeah, that looks kind of tiny, doesn't it? Anyways, like I said, I don't make it very clear on the exams. It's not going to be something you're going to have to worry about. So help me out, Andrew. Maybe help me calculate the rise or the run. How much of a rise do I get? All right, close. Since you're going down, the rise would be -5. And then you're right, the run is 6. So the right would be 6. So let me capture that for the video. So we're going to use these 2 points, this one here, and 6, -2. So the rise would be a -5 because you're going down, and the run is a +6. What's the y-intercept? 3. Y equals -5, 6x plus 3. Please make sure you remember to put in the x. -5, 6 plus 3 would just be, what, 2 1/6 to be a horizontal line. Without the x, it's off. All right. Does that help out? Okay, good. I think we practiced some of these the other day. Let's go back and do some more here. Parallel, perpendicular, or neither. So some people call this laziness. Instead of writing it out, I just use some math symbols here. I call it economy of movement. All right, parallel, perpendicular, or neither. What does it mean if two lines are parallel? What has to be true?
They never cross. They never intercept each other.
What's true about their slopes?
They zero.
Not necessarily just zero. What's true about two parallel lines of their slopes?
Oh, they have the same slope.
The same slopes. So M1 equals M2. Perpendicular lines, that means that M1 is the negative reciprocal of M2. So there's kind of a quick reminder there. Let me give you an example. Parallel lines, you could have slopes of, say, 8 and 8. Perpendicular lines, you could have slopes of M1 would be 8, M2 would be negative 1/8, opposite and reciprocal. This is kind of nice because it takes advantage of slope-intercept form and a little bit more in terms of parallel and perpendicular lines. We'll start out with a nice warm-up problem. Problem number 76. Y equals negative x minus 3 and y, excuse me, negative 9x minus 3 and y equals negative 9x. So the question is, are these lines parallel, perpendicular, or neither? Well, what are you going to have to do to decide? All right. What's the slope of the first line? Good. How about the slope of the second line? Negative 9. Good. So are these lines parallel, perpendicular, or neither? Parallel. Good. Yeah, absolutely. So parallel, scratch off those. Let's try problem number 80. Y equals 3x minus 15. Y equals 1/3 x plus 4. Again, parallel, perpendicular, or neither. Let's see, I left off the negative here. That's a negative there. Negative 1/3 x. So, first things first, determine the slope of each of these lines. What's the slope of the first one? 3. Slope of the second one? Negative 1/3. All right. Ted, are these parallel, perpendicular, or neither? Good. They're certainly not parallel, right? You can knock that one off because they're not the same. And perpendicular, well, they're negative reciprocals. There's actually another way you can test whether or not two lines are perpendicular. If you multiply their slopes together, this times this, you'll always get negative 1 for perpendicular lines. Always. Except in the one case where you've got undefined and 0. But other than that, the product of their two slopes is going to be negative 1. All right, let's make them harder. Problem number 82. Y equals 3/4 x plus 1 and 4x minus 3y equals 15. Now I'll be very helpful. The slope of the first line is 3/4. Yay! It's up to you to figure out the slope of the second one and decide if they're parallel. What should I do here? Micah, what should I do with the second equation? Just to kind of get rolling. By what? All right, we can divide everything by -3. That'll give me -4/3 x plus y equals -5. Can I determine the slope there? Is it in slope-intercept form? No. What do I need to do to put it in slope-intercept form? What needs to change? I need y by itself. So this term has to move to the right-hand side. When it moves to the right-hand side, what's going to change about it? The sign's going to change. It's going to be +4/3 x minus 5. Yes, sir. Did you move the 4x first and then divide by -3? Yeah, that would have been my inclination, but it works the same either way.
Is it okay if you divide by -1 on both sides first and then divide by +3 on both sides and get the same thing?
Sure, sure. I mean, that works as well. I mean, dividing by -1 and then dividing by 3, that's doing in 2 steps what we did here in 1, but if you're more comfortable that way, then by all means do it. So, same question. Parallel, perpendicular, or neither? Well, let's do the easy part first. Are these parallel? What would have to be true if they're parallel? They'd be the same. Are they perpendicular? Why not? What would the slope have to be here in order for them to be perpendicular? -4/3. So they're not parallel, they're not perpendicular. Guess what? Neither. And that's going to be the case for a lot of your lines, so that they're not going to be either parallel or perpendicular. Yes, sir.
I need to know where you got 4x minus 3y equals.
That's the equation that they gave you to start with. They asked you to decide if this line here and this line here above my pen were parallel, perpendicular, or neither. So, yeah, they gave it that. They gave us that to start with. So let me circle it in yellow. This is what we started with. You had to decide if those two lines were parallel, perpendicular, or neither. The way we had to work it was we found the slope of each line. Finding the slope of this line really meant that you had to put it in the slope-intercept form. So we divided everything by -3. That gave me this equation down here. And then I just picked this term up and moved it to the right-hand side. When a term changes sides, it changes signs. Okay. Do you want one more like that? Or are you good on these? Another one? All right, problem number 86. Y equals -3x plus 1. And 3y equals x minus 5. Ted, this is bringing me to a question I promised I'd answer to you on the board. Um, is this on slope intercept? Is this in slope intercept form? Right here? Can I look at that and say, all right, the slope is 1, the y-intercept is -5? Got to have y by itself first, right? So that would mean dividing everything by 3. And I get y equals x over 3 minus 5 over 3. And here's where I'm going to answer your question earlier. Like, well, how does that equal, a different fraction? You could rewrite this as 1/3 times x minus 5/3. And that wasn't too nice and neat. 1/3 x minus 5/3. Now this is next to the fraction. It's not in the denominator. But what you can do to justify that, if I look at x over 3, I could think of that as x over 1 times 1 over 3. Now what happens when you multiply things together that are fractions? You multiply their numerator and you multiply their denominator, right? I could also switch the order, 1/3 times x over 1. But instead of writing x over 1, I can just write x. So that's what justifies what we did earlier in going from like x over 2 to 1/2 x. Stuff like that. All right. So you don't have to show all the details here. You can just jump from here down to here. That's fine. No problem with that at all. So the question then is, what is the slope of these lines, and are they parallel, perpendicular, or neither? Let's start with the slopes here. What's the slope of this first line? -3. Slope of the second line? 1/3. Certainly they're not parallel. What has to be true if they're parallel? They'd have to be the same, right? They're clearly not the same. So on certain tests, sometimes you have to, answer all the questions and you're bubbling in things. And if you don't know the answer, then you're at least trying to eliminate some of the things that can't be the answer. This can't be the answer, so at least you got a 50-50 chance here now, right? So are they perpendicular? Yeah, they're opposite reciprocals. This times this would be -1. So that's true, and then the last one is neither. Correct, yeah. If this was a +3 and that was a +1/3, then yeah, you're right, it'd be neither. If they were both negative, then you are correct. They would, again, be neither. They're going to have opposite signs. Remember, they're going to have to multiply to give me a -1. So that means one has to be positive and one has to be negative. Because if they're both positive, you get a positive product. If they're both negative, you get a positive product. So they have to have opposite signs at the very least if you have any chance of them being perpendicular. Thanks for the questions, gentlemen. Let's finish this up. Let's look at problem number 98. Maybe we'll turn this into something a little more local. For lunch, a delicatessen offers a salad and a soda special where customers serve themselves at a well-stocked salad bar. The cost is $2 for the drink plus 42 cents an ounce for the salad. Write a linear equation that will find the cost of a salad and soda lunch when weighing X ounces is purchased. When a salad weighing X ounces is purchased. So, all right. Is it clear that this is going to be your y-intercept? That's your cost before you have any salad at all. When the salad is 0, If you're just doing a liquid lunch, then okay, then you're going to be spending $2. But then you're going to spend 42 cents per ounce for the salad. So what would that look like in terms of a linear equation? Yeah, the 42 cents per ounce is your slope. So y equals, or y is our cost, 42 cents. If I want to write that in decimal form, what would that be? 0.42 x plus 2.00. This is all in terms of pennies, but 42 cents per ounce plus $2 for the drink. Okay. Let me send out a little long distance dedication to my family. They like to go to Middle Earth right here in Royal Oak. So suppose they're going to get, maybe a pop for $2.50, and I forget how much it costs per ounce to get their frozen yogurt. Sweet Earth, yeah, I'm thinking of Lord of the Rings. Yeah, Sweet Earth. So what is it, about 55 cents an ounce maybe? So let's assume that it's 55 cents per ounce and $2.50 for the drink. So write an equation that represents that. Okay. Don, what'd you get? What would the equation be? 0.55x plus, 250. Cool. For homework, try 1 through 39, 43 through 51, 53 through 59, 63 through 71, 75 through 85, and 91 through 99. So I try to be pretty selective here and not just give you everything, but these are good problems, and I would definitely practice these. It's the only way you're really going to get good at this stuff. Still got sound? Yep. Good.